Hello students, welcome to Legacy IAS Academy. Today we are going to discuss about glacial landforms where we will talk about depositional landforms created due to the movement of glacier. So let us try to understand first of all that how all these depositional landforms develop due to glacial movement. So first of all, they develop as a result of something which we can call as glacial action. Now glacial action in simple words can be defined as the action by the movement of glaciers that include various phenomena such as erosion, deposition, as well as transportation, and collectively this is something that we can refer as a glacial action. As a result of this glacial action, it helps in molding of landscapes in the mid and the high latitudes as well as in the upper region of mountains and alpine environments. Due to the movement of glacial, especially in the upper region, as we know, we have discussed in the last video, erosional landforms develop such as valleys, fjords and all. However, when the glacial enters into the plain areas, when the movement of glacier becomes slower and slower, we have development of several depositional landforms as well. And the most important of these are eskers, outwash plain as well as drumlins, which is also called as basket of eggs topography. So let us try to understand first of all, that how many types of glaciers do we have? So as you know, on our Earth, glaciers can be found in two areas. One is in the higher latitudes, that is in the polar areas, and there generally glaciers are found in the form of ice sheets. In simple terms, ice sheets can be defined as extensive cover of the glacier, extensive cover of the ice covering a kind of continental landmass, expanding over a continental landmass. And it is these areas which experiences a very long period of extremely low temperature, or we can say sub-zero temperatures. And the most common example of this kind of areas, as we know, is Antarctica in the southern hemisphere and Greenland around the Arctic region in the northern hemisphere, which are almost completely covered by ice sheets. Not only that, we also find glaciers in the mountainous environment if the altitude is so high that the temperature becomes less than 0 degrees Celsius. So in that situations, the glaciers that develop are called as alpine glaciers, and alpine glaciers are long and linear in nature, long and linear in shape, and they occupy high altitude mountain valleys. Due to the influence of gravity, the glaciers then start to flow down the valley, and as they flow down the valley, continuously see the increase in their sizes due to accumulation and absorption of smaller tributary glaciers. This is very much similar to the flow of rivers as well. For example, when a river stream originates from a particular part of mountain, as it moves in the downward directions, it takes up water from the surrounding tributaries, and when it finally enters into the plain, the volume of water flowing the rivers become immensely high or humongously high. So same thing happens in the case of glacier as well. And such kind of glaciers, which is called as alpine glaciers, are found across major mountains of the world which are having high altitude such as Rockies in USA, Andes mountain in the South America, and Himalayas in the Asia including India. So these glaciers are basically high latitude, polar or Arctic mountains such as those in Alaska ranges. Also we see alpine glaciers. So it is due to the movement of these two kind of glacier we see development of deposition landforms. However, the flow of alpine glaciers predominantly develop or lead to development of the in modern circumstances lead to development of the deposition landforms. So one of the most notable glacial deposition landform which we are going to talk first is what we can term as moraines. Moraines are such kind of depositional feature that develop due to the glacial till deposition as the glacier melts as it reaches in the downward direction, it reaches in the plain areas. Because as you know, if the altitude decreases, we see continuous increase in temperature, and this continuous increase in temperature then causes the melting of glacier. And when the glaciers start to melt, it try to deposit whatever sediment it is carrying along with itself, leading to formation of moraines. So in other words, we can say moraines are nothing but the pieces or fragments of rock which has been shattered, which has been broken due to the action of glaciers such as frost action, which are embedded in the glaciers and then brought down the valley by the glacier. And once glacier melts, these rocks start to deposit themselves in a particular fashion, and that is what we can term as a moraine. Now, on the basis of how deposition is taking place, where actually is deposition taking place, we can identify four common types of moraine. These moraines are lateral moraine, medial moraine, end moraine, as well as the terminal moraine. So let us try to understand each of these moraine and how they develop. So the first and foremost moraine which we have to talk about is lateral moraine. So lateral moraine in simple term can be defined as long linear ridges of glacial till which is deposited along the side of the glacier and parallel to the direction of its movement. For example, if you look at this picture, you can see the glacier is coming from the upward region of a mountain, and as it is descending in the downward direction, what is happening is the deposited fragments of rock, the fragment of rock that is carried by the glaciers are deposited in the sideward part of the glaciers, and these black rocks that you see here is what we can call as a lateral moraine. As you can see in this case, we have two glaciers. This is we can call as glacier A, this is glacier B, and that is why both glacier A and B are depositing the sediments on both of their sides. So till the glacial till that fall on the side of glacier form what we can call as lateral moraine. Now, if you look at the same picture again, the another kind of moraine that forms is called as medial moraine. So medial moraine, the name and term is derived from the simple logic that these develop in the middle part of a glacier. So medial moraine can be defined as a long linear ridges that form along the contact where tributary glacier with lateral moraines merged to join larger valley glaciers. What does it mean? It means again, if you look at the same picture, this is glacier number A, this is glacier number B, and both these glaciers A and B carry huge amount of rock fragments, sediments along with themselves, and so this is the side of B and this is also the side of A, and as the moraines are deposited on the sides of A and B, they merge together to form a common moraines, and this common moraine is what we can refer as a medial moraine. So we can say the till deposits become incorporated as dark ridges of sediment oriented down valley and aligned parallel through the middle of the glacier. Many times what can happen that instead of two glaciers we can have 4 or 5 glaciers, and at the central part of two glaciers we'll always have medial moraine. So in many parts of the world you will see a series of moraines that is developing due to flow of numerous glaciers from the upward region of a mountain slope. The third type of moraine which we can talk about is terminal moraine. So terminal moraine can be described as again a linear but concave and arc shape of moraine that is deposited at the terminal end of the glacier. Terminal end of the glacier means the endward portion, the snout of glacier in the downward valley. And thus the till deposit marks outward expanse or limit of the glacial movement. That means beyond that there is no glacier present. This is the maximum extent up to which we can find the glacier. So basically what happened, as glacier flows in the downward direction, eventually due to the rise in temperature, the ice of glacier melts, and on reaching the foot of the valley, whatever transported materials, the pile of transported materials that glacier has been carried along with itself, now obviously since it has melted, it cannot carry it along further, and thus they are left behind at a snout, leading to formation of terminal moraines. So again, if you look at this picture is glacier A here, glacier B here. This is our lateral moraine. This is our medial moraine, and in the concave arc shape, we have what we can refer as terminal moraine. Now, what happens? Sometimes another kind of moraine that develops before terminal moraine, which is referred as end moraine or recessional moraine. Recessional or end moraine are also very similar in shape as compared to terminal moraines, and they are also concave arc shaped ridge that is deposited by the melting glacier. But the difference between terminal moraine and end moraine is that end moraine is smaller than the terminal moraines in size, and they mark the gradual retreat of the glacial ice after it has already deposited its terminal moraine. So to understand it, simply suppose this was the snout of the glacier. This was the place where the glacier has deposited and formed a terminal moraine. Now what happens as warming occurs, glacier also try to retreat backward. So when it is retreating backward, after some time glacier might reach here, and here also it will deposit some of the sediments. Again it will retreat further backward, and here also it will deposit some sediments. So this is our terminal moraine, and this the moraines developed due to the continuous retreat of glaciers is what we can refer as end or recessional moraine. The deposition of end moraines may be in the several succeeding waves, as I have drawn the picture here, and as the ice may melt back by not the same time but in several different stages, and thus a series of recessional moraines are formed. This is something you can also see from this particular picture. This is your glacier which is right now retreating in the backward direction, and here we can understand that might be terminal moraine might have formed here, and as the glacier is retreating, another wave, a series of deposits, glacial tills are being deposited, leading to development of recessional or end moraine. So overall, what we can understand that moraines are of four types. If you look at this particular picture, you can clearly understand that how the deposited sediments are known by name of different moraines depending on their place. So this is the lateral moraine that is deposited on the end of end of the glacier. This is medial on the in the middle portion of two glaciers. Then we have terminal, that is the outermost deposits by the glacier, and then we have the wavy deposits, concave shape deposits as the glacier is retreating back. So these are the four types of moraine. Sometimes another term that is used is what we can refer as ground moraine. So ground moraine refers to such moraines, such glacial tills and sediment which are situated at the bottom of the glacier or beneath the glacial sheet, beneath the ice sheets of glacier. So that is another term you can keep in mind. Now, apart from moraines, another significant and interesting, very interesting landform that developed due to the depositional work of glacier is what we can refer as drumlins. So, drumlins are basically shape wise they are oval in shape, structure wise they are again long and linear, but they are a kind of small hills which is deposited due to the movement of glacier, and when the glacier finally retreats back, these deposited sediments take up a hill-like or hillock-like feature, with one side being very steeper. We can say this is the directional movement of glacier. So the side where glacier is moving from, that side is much more steeper, while the leeward side, as you can see, is kind of having a very gentle slope and is elongated in that direction. So that is how generally a drumlin look like. So drumlins basically they are not found as separate structure, but the drumlin areas are filled with numerous such drumlins, and since there is large number of drumlins you can find in the same region, the overall topography is also called as basket of eggs, because if you look at from the top, due to the oval shape and elongated shape of the drumlins, it looked like egg, and since there are large number of drumlins there, it looked like there is an arrangement is in the form of basket of eggs. To show you the actual picture, this is a picture that is taken from the Scotland, and as we can see, this is the one drumlin, this is the second drumlin, third drumlin, fourth drumlin. So all across this region, just at the foothill region of this mountain slope, you can see the deposition of this glacial till, and this collectively this area can be referred as basket of eggs topography. Then coming to the next important landform that develops in the plain region by the glacial movement is what is referred as eskers. Eskers are not directly forming due to the movement of ice sheets, but eskers develop due to the meltwater channels that is entrapped within the glacial sheets, within the ice of the glacier, and it seems like these meltwater channels are emerging in a tunnel or from a tunnel beneath the glacier. If you look at this picture, it will become more clear. For example, this is overall entire glacier, and many times due to the rise of temperature here and there, we have the melt water that forms. And many times this melt water enters below the glacier, enters within the glacier, and then it forms a kind of what we can say as a tunnel in between the glacier sheets. And thus, when the glacier start to retreat back, when the glacier start to melt, whatever sediments that is being carried by this meltwater glacier will start to get deposited in the shape of a ridge. And most of time, these ridges are made up of sediments such as sands and gravel, which basically mark the course of the melting glacier, marks the course of this moving meltwater channel. And thus, as meltwater channel disappears, the water and the ice disappear. This ridge-like deposition stands there, and that is what we can call as esker. If you look at the actual shape of esker, this is how it look like. For example, this is the landmass. You can understand that in Pleistocene period, this entire area was covered by thick volume of glacier, thick ice sheets, and below and between this ice sheet, there must be a meltwater which has deposited these sediments in this kind of shape. So we have number 1 esker, number 2 esker, number 3 eskers. And now since the temperature has increased, Earth has entered into warming phase, the entire area is free of glacier, but the sediment deposited by the glacier and meltwater can be found here and there. So this is the eskers. Then another interesting topography which developed in the plain region due to glacial movement is what we can refer as Kames and Kettles. Since both Kames and Kettles are found adjacent to each other, the entire topography many times is also referred by geologists and geographers as Kames and Kettle topography. So what is a Kames? Kames are nothing but again small hills or irregular mounds of bedded sand and gravel which is deposited by the meltwater. Kames, however, tend to be stratified and generally associated with the surface deposits. For example, what happens if suppose a glacier is moving like this, but as it goes more and more in downward direction, temperature increases. Thus, the ice will not be able to retain its solid phase. It will enter or it will convert into liquid phase. And thus, we have streams that originate from these ice sheets. And these streams also carry along with themselves large amount of sediments. And when these streams deposit the sediments, what we can call Kames is what we can call forms here. Similarly, kettles are strong depressions, large to small depressions that develop in the outwash plains, and they are often filled with water post glaciation. So let us try to understand how kettles form. For example, this is picture number 1. So if you refer here, this is the time when the glacier is on the retreat. So the main block of glacier is retreating in the northern direction. However, here and there what happens, the ice, large to small ice fragments of these glaciers remain trapped in these plain areas. Now what happens, gradually there will be development of the plains, sediment will be deposited by the retreat of the glaciers as we have discussed before. So this entire dead ice block that has remained here and there will get filled up or will get surrounded by this huge accumulation of the sediment. Now gradually what will happen, this ice block cannot remain in a solid state because temperature is increasing, temperature is higher here. So gradually this ice block start to melt. But as this ice block start to melt, the area that has been enclosed or that area that has actually been encompassed by these ice sheets, ice block, they will actually remain as so and will thus kind of depression, a kind of vacant area will form in the plain areas. And as the ice sheets are melting, it will convert into water. So many times the water will fill up this depressed area, water will fill up this subsided area, and thus will have formation of kettle holes and kettle lock lakes as well. So both we can say subsidence and the melting can cause deepening of the kettles, and kettle lakes are surrounded by either rainfall or snow. For example, if you look at, this is the picture taken from the Canadian region, that is an Arctic region, and here and there see all these lakes that you are seeing in the outward plane of the glacier movement. These are the examples of kettle lake. So this is how you have formation of kettle lakes in the outward plane of the glacier during the post-glaciation period. Another landform that is a depositional work of glacial movement is what is called as erratics. So erratics are nothing but large isolated boulders, big rock pieces that are deposited by the retreating or melting glacier. So again, same phenomena happens here. Suppose this is your glacier. Now we know that within the glacier, a lot of large rock pieces, rock fragments are enclosed. But as the glacier start to retreat or as it start to melt, what happens, the surrounding ice blocks that is covering earlier this entire stone blocks, entire boulders, start to disappear, and thus boulders start to appear here and there due to the melting of the glaciers. So generally they are believed to be left behind, the largest rock that are left behind by the retreating glacier. And since the glacier has continuously been moving over this kind of boulder blocks or rock blocks, they appear very smooth due to abrasional process. And also because if you try to imagine this, earlier this entire area was filled up a glacier, but now since the entire glacier has retreated, but this large boulder rock has been remained here or has been left behind, thus it seems very misplaced in the landscape. It does not seem that, it seems that from where it has come from, it becomes very mysterious, but it is the depositional work of a glacier, you can say. For example, if you look at this picture, you can see a large stone slab boulder rock is there, and around that area you have a kind of plain region. Here also you can see this is large boulder block is there, and around that area you have kind of very small rocks and a plain area. So that is why we can say it seems very unique and misplaced in its environment, in its surrounding, and that is why you can call it as a erratic, because it has a erratic kind of behavior. The most important and the last landform that is developed by glacier is what we can refer as outwash plain. Outwash plain is basically formed due to fluvio-glacial deposits. Fluvio-glacial deposits refer to the deposit that is formed due to both movement of glacial as well as deposit that has the sediment that has been deposited due to the melt water from the glacier or within the glacier. So as the deposits are washed out from the terminal moraines by the streams of stagnant ice masses, we see the development of extensive stratified because we have multiple layers of the sediments that are being deposited and different types of glacial till that is being deposited below a glacier. So the entire plain is choked with glacial tills and are fed by melt water that is flowing from the base, the outward portion of the glacier, and most of the time they often create a braided stream where the stream seems to not flow in a single direction or a single path or single channel, but rather than it splits, it merges, then again it appears to be remerging with each other, again it separates out, again it merges. So this kind of flow of water is what is called as braided stream, which you'll also see in the deltaic regions of the river. So due to the flow of this braided kind of streams emanating from the glacier, we have the sediment deposition, and thus finer sediments are transported to a much more longer extent, farther extent in the downstream areas, while the larger sediments are deposited earlier. Thus we have a gradation of sediment deposit you will find in the outwash plain of the glacier. So overall, again, if we revise that what are the major landforms we have discussed due to the glacial deposition, that we have eskers, we have drumlins, which is also called as basket of topography. As you can see from this, we have the ground moraines, then we have the ice blocks. When they are left behind, they are called as kame, and when the depression forms and when it is filled up by water, it is called as kettles and kettle lakes. Then we have different types of moraines such as turbinal moraines. This you can see is your recessional moraines, and then this is the outwash plain formed due to the melt water flowing in a braided stream kind of shape and depositing huge amount of sediment according to their sizes from upper part to the lower part of this outwash plain. So that is all about this particular video. I hope you understood about the major depositional landform developed due to glacial action. If you like the video, please hit the like button, share it with your fellow aspirants, as well as subscribe to our channel for more such helpful content. Thank you very much.